Now let us go to the vector product. Again, the vector product is called the cross product, and this is denoted by your A cross B. The result of your vector product is itself a vector quantity. To define the vector product A cross B, what we do is we draw the two vectors with their tails, just like your dot product, at the same point. That is, the two vectors should lie in the same plane. And the vector product is the vector quantity with a direction perpendicular to this plane. So if you imagine um, your A and B lying in the xy plane, perpendicular to your xy plane is your z-axis. So that means your vector product lies on the z-axis. So it is perpendicular to the plane containing A cross B. So that is your vector C, which is equal to your A cross B as a magnitude of AB sine phi. Again, phi is the angle, the smallest angle between your two vectors A and B. Now, let us have more about the vector product and going back again to our two vectors A and B. So suppose these are your two vectors A and then your B, and we want to find the cross product of these two vectors here. Okay, again, what we do is we put the tails of the two vectors at the same point here, and you have the angle between the two vectors theta. Take note here that we have actually two angles between your two vectors. The first angle is this one here, and the second angle is this one here. Okay, but in your cross product, what we take reference to is the smallest angle between your two vectors, which is your angle theta here. Okay, now here your vectors A and B lie at the same plane, and we look at this circular plate here as the plane in which your vectors A and B lie. The cross product of your vector A and B is perpendicular to this circular plane. In this case here, we have two directions, two sides, which is perpendicular to the circular plane. One is pointing upwards, and the other one is pointing downwards. But how do we know which of the following vector is the result of our cross product? So the best way to determine this one is if you're going to use your right-hand rule. So in the right-hand rule, we use our right hands, okay? Uh, for example, here you have your A cross B. How do we know if it is upwards or downwards? So we're going to discuss it in the next slide. So this is how you're going to do your right-hand rule, okay? In using the right-hand rule to find the direction of A and B, the first thing that you do is we place A and B tail to tail, just like on this figure here. And then we point our fingers of our right hand. So we use our right hand. This is mirrored. What you see is mirrored. So this is my right hand. Okay. Again, this is my right hand. We point the fingers of our right hand along A with the palm facing B. Or you can actually use these three fingers here. So you have your pointing finger, your middle finger, and then your thumb. Okay. We are going to use these three fingers here. Okay. Here, it's stated that we point the fingers of the right hand along A with the palm facing B, and then curl the fingers toward B, and the thumb points in the direction of A and B. If you're going to use the instructions here, what you do is we place we place our fingers, the right hand along A. So for this example, the A points here, okay, with the palm facing B. So this point towards B, and we curl the fingers for B. So your B is going up out of the page. So we curve. Okay. Your B points outward. So we curl B. The thumb points in the direction of A and P. Okay. If we're going to use our three fingers, so your pointing finger points to your first vector, your middle finger points to the second vector, and then your thumb, it represents the direction of the third vector. So again, for this example, your vector A points here. Okay, try to point your fingers in the direction of A, and then your thumb goes out of the page. So like this one here. Okay, you're going to look at this is again your vector A, and then your vector B. The thumb points the direction of the cross product of A and B. Okay, now how about B cross A? Is it the same with A cross B? So if you want to look at the B cross A, okay, by using our palm, okay, we point first towards B, toward B, so our B here, and we go to your A. However, your A is at the back of this hand. So in order to curl that one, we go this way and curl. Okay, we curl, and the direction of our thumb is downwards. So your B cross A has a direction which is downwards. So it is not the same with your A cross B. If we use again our three hands, your pointing finger points to our first vector, your middle finger is the second vector, and our thumb is pointing to the direction of your cross product. So if you want to find your B cross A, first point towards your B, and then your A, okay? Your A is at the back, okay? This is your B, and then this is your A here. So your B cross A points downward, okay? Let's look at the cross product of your unit vectors and consider again here your XYZ plane. Again here, we have a unit vector I hat that points in the positive x direction and a unit vector j hat along the positive y direction, and then we have a unit vector k hat pointing along the positive z direction. Okay, we usually have this kind of a technique in finding the cross product of your unit vectors. Okay, you have your I hat, your j hat, and then your k hat. Let's try to look at the cross product of your I hat cross your j hat. If you're going to look at here, your I hat and then your j hat plane is the one in blue. Okay, you can see that one there. And by looking at that plane, your blue plane, you see that we have two perpendicular lines or perpendicular directions with your blue plane. You have your positive k hat going to the positive z direction, and then also have this one, your negative k hat going towards the negative z direction. Okay, if you're going to use your right hand rule, you know that your I cross j, this is equal to your k hat. Okay, the technique actually here is, if we're going to look at this one here, is ijk axis. If you're going to go counterclockwise, we have a positive result of the cross product. If we go clockwise, we have a negative result of the cross product. So going from I to j here, we have your k hat. If we have your j cross k, okay, your j cross k, go from your j towards your k, our result is a positive I hat. Okay, we have here positive I hat. And if we go from k to I, your k cross I, that means we go from here to here again, it is counterclockwise. So our result is the positive j hat. If we go um, clockwise, okay, you remove this one for a while. If we go clockwise, say from you have your I cross j, okay, sorry. If we go from you have your I cross k, so we go clockwise here. Our result is j hat, but this time it's a negative. Also basing from your, or you can verify this one using your right hand rule, okay, and so on and so forth. So you have your k cross j, you have negative I hat. If you have j cross I, you have negative k hat, okay? Now, how about your I cross I, your j cross j, and your k cross k? What are these things? Okay, remember that your um, you have the magnitude of your cross product C. That is, this is equal to your AB sine phi. And if we have two vectors that points in the same direction, meaning your theta is equal to 0, or you can also say that your theta is equal to 180, meaning they are antiparallel. Okay, sine phi, your sine phi will go to 0. So if we cross product two vectors that lie in the same line, it goes to 0. Going back to our two vectors A and B, again you have your vector A written in unit vector notation. We have AX I hat plus AY J hat plus AZK hat, and then your vector B, you have BXI hat plus BYJ hat plus BZK hat. Okay, and say we want to find the cross product of A cross B, we can do it manually by doing your ordinary multiplication. We start first with your AXI hat, multiply it with your BXI hat plus your AXI hat, multiply it with your BYJ hat, and then your AXI hat, cross product it with your BZK hat. And after you're done with it, we start with your AYJ hat, multiply it with your BXI hat plus your cross product of your AYJ hat, J hat, and then BYJ hat, and then you have your AYJ hat cross BZK hat, and then lastly you have your AZ. So you distribute it. Okay, you can do that one, but that is quite tedious. So another way to do it is by using your determinant method. So the components of your cross product can be calculated using the determinant method. And in the determinant method, we are going to draw a 3 by 3 matrix like this one here. Okay, so on your 3 by 3 matrix, you write first on your first row your I hat, your j hat, and your k hat, or your unit vectors. And then since this is A cross B, we write on the second row first the components of your vector A. You have AX, AY, and AZ. And on the third row, you write your BX, BY, and BZ. If instead this is P cross A, on the second row, you write first your B components, and on the third row, we write our A components. So the order of multiplication here is very important. Okay. The technique here, if you're not familiar with your determinant method, so we're going to find determinant on a 3 by 3 matrix. But if you have not yet encountered this one in your algebra, what you can do is you can extend this one, okay? By adding again, you have your, this is just your imaginary extension. You extend this one. This is easy. Okay, this is bx, and then extend again here at the hat. You have your ay and then your by. Okay, so what we do is for your a cross b, or a cross b, okay, we hide this one. We carry your direction I hat. So what we do is we multiply your ay times your bz, and then subtract it by the product of az times by. So this is ay times bz minus az times by. Okay, and we carry the direction of your I hat. Okay, so that is the first term. Next, we hide this one, this area here. Okay, and we always go to the right. So going to the right, we add the next terms. So we multiply your az bx minus your ax bz. So that is your az bx minus your ax bz. Okay, and we carry the direction of your j hat. And then lastly, okay, lastly, you can hide this one here. Okay, and we do the cross product of your ax by minus your ay bx. So that is your ax by times by minus your ay bx. And we carry the direction of your k hat. So this is how you do your cross product of your vector components using the determinant method. Let us have an example of your vector product. We are given here two vectors a and b. Your vector a of 2I hat minus 4j hat minus k hat, and your vector b minus 6I hat minus 3k hat. So find the cross product of a cross b. So again, you can do it by your traditional multiplication, or you can also do it using your determinant method. So let me just use the determinant method. So again, I draw a 3 by 3 matrix. On top, you have your I hat, your J hat, and then your K hat. So we have on the second column your 8 components. You have your 2, minus 4, and you have 1. And on the third column, we have a negative 6. So on J hat, you have nothing, so you have 0. And then you have minus 3 on your K hat. Okay, so just extend this one. So you have 2, negative 6, and here we have negative 4 and 0. And we start doing with your cross product, your A cross B. So first, I have negative 4 times negative 3, that is 12, positive 12, minus 1 times 0, that is 0. This is I hat plus, okay, plus this one. So I have 1 times negative 6. So you have minus 6 minus 2 times negative 3. So that is negative 6. Okay. Minus 2 times negative 3. So that is negative 6. So minus 6. And then you have your J hat plus. Okay. You hide this one. So we have 2 times 0 is 0 minus negative 4 times negative 6. So that is plus positive 8 minus positive 18, or sorry, that is positive 24. So you have minus 24. And then we have your K hat. Okay, so you have 12 I hat plus, you have here negative 6 plus 6, so 0. J hat plus, you have 0 minus 24, so you have negative 24. K hat, or this is simply written as your 12 I hat minus 24 K hat. So this is your A cross V. So that ends lesson 1 on units, physical quantities, and vectors. Thank you for watching. See you in the next lesson.